Good evening, everyone, and welcome to the session 8 from the playlist of System of Particles and Rotational Motion. The topic is the angular velocity and angular acceleration. And based on this point, I have written here three important points which will help us to understand these two topics in brief. So, the first point is basically the definition of angular velocity, and angular velocity is the angular displacement of an object with respect to time, and angular velocity is taken as positive if the body is moving in or it is rotating in a counterclockwise direction, and angular velocity is taken as negative if the body is rotating in a clockwise direction. Angular velocity is denoted by omega, and omega is equal to theta upon t, where theta is the angular displacement and t is the change in the time. Now, if delta theta is the change in the angular displacement in the time interval delta t, then the average angular velocity is given by delta theta upon delta t. And if delta t is tending towards 0, that is delta t is very small, then in that case this equation, that is the average angular velocity, that is omega av is equal, which is equal to delta theta upon delta t, can be written as omega ins. This omega ins is the instantaneous angular velocity, which is equal to d theta upon dt, and we have got this equation when delta t was tending towards 0. So, when delta t is tending towards 0, then delta theta upon delta t will be equal to d theta upon dt, which is the instantaneous angular velocity. So, the important point here from the first point is that angular velocity is positive when the body is moving or it is rotating in counterclockwise direction, and the angular velocity is negative if the body is rotating in the clockwise direction. So this is the basic convention which we follow. And if delta theta is the change in the angular displacement in the time interval delta t, then the average angular velocity is equal to delta theta upon delta t. And if delta t is tending towards 0, then the instantaneous angular velocity is given by d theta upon dt. Now, the direction of the angular velocity is given by the right hand rule, that is if the curled fingers are in the direction of rotation of an object, then the thumb will point in the direction of the angular velocity. So this is the right hand rule, and we can find the direction of the angular velocity by using the right hand rule. The last important point is that the linear velocity is equal to r into omega. So if delta v is the change in the linear velocity in a time interval, say delta t, and delta omega is the change in the angular velocity in the time interval delta t, then this equation can be written as delta v upon delta t, that this is equal to r into delta omega upon delta t, where r is what? It is the radius of that rotational motion. Now, if delta t is again tending towards 0, that is if delta t is very small, then in that case this equation can be written as dv upon dt, which is equal to r d omega upon dt. Now, dv upon dt is this is called the tangential acceleration. At is the tangential acceleration, and this is equal to r into alpha, where alpha is the angular acceleration. Now, alpha is equal to d omega upon dt. Basically, it is the rate of change of angular velocity, and at is the tangential acceleration, which is equal to the rate of change of linear velocity. So this is an important relation, that is at is equal to r into alpha. Here at is the tangential acceleration and alpha is the angular acceleration. Then the another important formula is that omega is equal to theta upon t. The average angular acceleration is equal to delta theta upon delta t, and the instantaneous angular acceleration is equal to d theta upon dt. And the linear velocity is related to the angular velocity by the formula is v is equal to r omega. And from this relation, we were able to find the value of, or you can say the relationship between the tangential acceleration and the angular acceleration, which is equal to, which is given by this equation, that is at is equal to r into alpha. So thank you very much for joining this session. In the next session, I will be coming up with a question which will be based on the topic of angular velocity and angular acceleration. So till then, have a nice day. Bye.